12 is negative 23 centimeters. 14 part A is 11. I guess it's not part A. The answer for A, or whatever that is 11. B is 16, and C is negative 8. 16, T is equal to C. Did y'all do 18?
No.
Okay. So that's all of the evens. Any questions about anything on the homework? Big way. 27, all right. Filling milk cartons.
Am I using the trapezoid mode on here?
I'm sorry, was that a question?
Yeah.
Yeah, it says use trapezoidal rule.
Okay. I didn't get the same answer.
Oh, you didn't get the same answer that they did? All right, so that is a weird looking table. Oh, it's from 8 to 6. So every time interval is an hour, right? 8 to 9, 9 to 10, 10 to 11, 11 to 12, 12 to 1, yada, 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 right? So kind of like we did the other day, we can factor out the 1/2 and the 1, right? And then I'm going to have the first one and the last one each once, but everything else twice. That's what's called, when it says the trapezoidal rule, that is the trapezoidal rule, that you factor out the 1/2, you factor out the interval, which should be the same, and then you're going to use 120 once.
Oh, I got that.
I'm sorry?
I got that.
Okay. I won't write out the whole thing, but plus yada, yada, yada through only one of the 121 at the end. All right, other questions? Yes, sir.
I like how to do it, but I still couldn't really get it. 25B.
25B, okay.
It's the quadratic regression calculator.
Oh, how do you do it? A quadratic regression on your calculator?
Yes.
Okay. Well, y'all have done linear regressions, right?
I forgot it now.
And Brett's like, I've slept since then, dude.
Yeah.
So you go to Stat. You want to edit. I'm going to clear out anything that's in there to begin with. Be sure you're clear and not delete. Delete deletes the entire thing, including L1. You can do it, you can get it back by resetting it, but it's not particularly fun.
I did that before. I'm missing L3 in my calculator. I haven't reset it.
It's easy enough to do.
Yeah.
But how often do you use L3?
Not often.
Not very often. All right. So, and we want it to be in years since 1995. So we're going to have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, right? And then 5, 8.9, 16, 26.3, 39.8, 56.5, 76.4, 99.5, 125.8, 155.3, and 188. And then you go back to Stat and tell it to calculate, and you just go down to the quadratic regression. And I have my X values in L1, I have my Y values in L2, There is no frequency list. That sometimes comes up. That is something that sometimes you'll use L3 for, as a frequency list. I am going to go ahead and store it as Y1. If you do alpha trace, you can get to Y1 without having to type weird stuff. And then you go, okay, calculate that. And that's the quadratic regression. This is definitely one where they cooked the books. There's no way the quadratic regression came out to be that nice.
Yeah.
They actually, what they did was they wrote an equation, wrote down the data points, and then said, this is some random data we found. And I'm like, no, it's not. Data is never, well, you've taken stat. Data is never this nice. I was like, what is that? So is that your primary question, was how do you get the quadratic regression?
Yeah.
Okay. Anything else? Okay. Then let me give you today's notes. No, that's not it. No, did I not take them out? Tearing it out. All right, so today we're going to look at a different application of using the definite integral called areas in the plane. We've done stuff with area where we found the area underneath a graph to the x-axis. But here what we're going to be doing is finding the area in between two functions. So if f and g are continuous on the closed interval from a to b, with f greater than or equal to g of x throughout, then the area between those two curves from a to b is given by the integral from a to b of f of x minus g of x. Because what is it that f of x minus g of x tells us? Well, it's telling us the distance between the two. Multiplied by a small width gives you an area, right? So then we add all those areas together, which is what the integral does, and we get the whole area. So let's do some. Find the area of the region between y is equal to secant squared of x and y equals sine of x from x equals 0 to x equals pi over 3. So the first thing we need to know is what does that look like from 0 to pi over 3? And since this is not a non-calculator problem, we do have to kind of know. Secant, you should know, kind of is a slightly U-shape. Secant squared would be even flatter and then more straight up and down. This first place where secant doesn't exist is where cosine is 0, which is what? What? Pi over 2, thank you. So pi over 3 less than that. And sine of x starts at 0. And by the time we get to pi over 2 is equal to 1. So it looks sort of like that. And we're interested in this area. Notice that secant squared is always above sine on that interval. So the area is simply the integral from 0 to pi over 3 of secant squared of x minus sine of x dx. Again, this subtraction just gives you the distance in between those two. So finding the antiderivatives, the antiderivative of secant squared is tangent, plus the antiderivative of sine is the opposite of cosine, so this will be plus cosine of x from 0 to pi over 3. Let's see, tangent at pi over 3 is 1 over the square root of 3, I believe.
saw it's square root
Tangent at pi over 3, oh, sorry, I did pi over 6. Thank you. You're right. I don't know why I did pi over 6. So it'll be the square root of 3 plus cosine at pi over 3 is a half minus tangent at 0 is 0 plus cosine at 0 is 1. And that's part of the cautionary tale here. A lot of you get kind of used to it being polynomials, and when this is 0, that second part is all zeros. Be really careful. It's not always. So this is the square root of 3 minus a half when you put it all together. Not very much area. These are frequently on the AP exam somewhere or another. It used to be that you could count on it being almost every year one of the free response questions asked something about area. Yeah, not so much. Okay, they've become much less predictable than they once were. But you'll find something like this either on the free response or on the multiple choice. Notice this is a calculator, primarily not for the antiderivative, but primarily for finding, well, where do these things intersect each other? Notice it didn't give you limits of integration here. So let's graph this. As always, especially if you are taking physics, make sure that you're in radian mode. So I'm going to clear out the previous inhabitants of the y1, etc. So I've got 2 cosine of x and x squared minus 1. And I'll do a zoom standard just so I can take a look at this, knowing that it's probably too small. That's not too bad. Let's zoom in at least a little bit on it. So there's my cosine graph, and there's my parabola. Notice we've got some nice symmetry here. So setting those two equal to each other, 2 cosine x equals x squared minus 1, means that x is going to be equal to, because of the symmetry, plus or minus something. We'll do second calculate the intersection. First curve, second curve, guess. Where's Lily when I need her? 0.683. Not even a little bit close. It was almost exactly half. Does that count for something?
No.
Bummer. Now, notice I'm not going to round that off because I'm in the middle of a problem. Okay, I don't want to round this. You're like, well, how do you keep from losing it? Well, it's pretty easy, actually. Notice if I type x now,
Wow.
it has that value in its head. And if you're afraid of losing it, tell it to store it as a or something. Now, even if it changes the value of x for some reason, it's not going to change that value. So my area is going to be equal to the integral from negative 1.265 yada 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 to positive 1.265 of 2 cosine of x minus x squared minus 1 dx. And although I'm not big on calculator tricks, I am big on using it efficiently. So when you do math 9 to get your integral, I've got, sorry, I need the opposite of a to a of, and I could type those again, and they're not too bad. But if they are ugly at all, I strongly suggest that you do this. They were in y1 and y2. Why type them all over again? And we get that the area is approximately 4.995. At that point, it's appropriate to give your answer to 3 decimal places because that is your final answer. Now, if you had rounded these off to 3 decimal places, would it have changed this? Maybe,
A little bit.
maybe not.
I got kind of similar.
Pardon?
I use it. I run it. It's kind of similar.
Yeah, it's not a good idea. Sometimes it will, sometimes it won't. It depends on how much these change over the interval. Since these are pretty small numbers, it's not a big deal. If these are really large numbers, it can be. Okay? All right, moving on. So, this is a problem that I think is in your textbook. I really like this one. We're going to do one problem 3 different ways.
So fun. You know, there's so many problems I do, and I'm like, let me think of 2 more ways I can do it.
Well, the only time I think of other ways to do it is there another way to do that that would be a lot more efficient?
Yeah, that's true.
So,
Let's do the most efficient way.
well, we're going to do it the 3 ways, and then I'll let you decide which one you think is the most efficient.
Fair enough.
Okay. Find the area of the region R in the first quadrant that is bounded above by y equals the square root of x, and below by the x-axis, and by y equals x minus 2. Like, okay, I need at least a reasonable sketch of this. I'm only in the first quadrant, though, so that helps. I've got y is equal to the square root of x. Hopefully all of you know how to graph that. It looks something like this. Y equals x minus 2. Well, let's see. That's 0 at x equals 2. And has a slope of 1. If I kept drawing it, it would look like that. So it can be confusing sometimes as to, well, which part of this are they talking about? Well, notice it says the above part has to be that half of a parabola. So this must be the upper boundary of your region no matter what. Then it says the lower boundary is the x-axis and this. So what that means is it's the x-axis to here, and then it's this line to here. So the first method we're going to look at is dividing that into two regions. I can divide that with a vertical line at x equals 2. So what I'll do is for the first region, the area will simply be the integral from 0 to 2 of the square root of x, which I'll write as x to the 1/2 dx, plus, for the second region, it's the integral from 2 to something, we'll figure out what the something is in just a second, of the parabola minus the line, right? When I take any little slice, it's parabola on top, line on bottom. So that'll be x to the 1/2 minus the quantity x minus 2 dx. How do you find this other limit of integration? Well, it's where is the square root of x equal to x minus 2? You might be able to guess it faster than you could work it out. Yeah, it's x equals 4. If you had to work it out, you would probably need to square both sides to get rid of the square root, and then you may be able to factor. So this is going to be from 2 until 4. So here I've got 2/3 x to the 3/2 from 0 to 2 plus 2/3 x to the 3/2 minus 1/2 x squared plus 2x from 2 to 4. So this is going to be 2/3 of, that's the square root of 2 cubed. So that's 2 square roots of 2. Because it's the square root of 2 times the square root of 2 times the square root of 2. Plus, let's see, if I substitute in 4, that's going to be the square root of 4 is 2 to the 3rd power is 8. So that's going to be 16/3 minus 8 plus 8 minus 0 plus 0. At least that part was nice. So this is 4 square roots of 2 over 3 plus 16/3. Woof. Not exactly the most attractive answer. Now, another way that you can do this, and being able to do this second one is really important for things that we'll do later on. Do it as one region, but do it in terms of y instead of in terms of x. So let's go back to what our diagram looked like. We had this half of a parabola. We had this line. So if I have y is equal to the square root of x, squaring both sides, that means x is equal to y squared. And my line, what was the equation of the line? Y equals what?
X minus 2.
So that means x equals y plus 2. Now, we're used to doing Riemann sums where we slice everything vertically, right? Because we're incrementing it in terms of x. But we can also, just as easily, increment in terms of y. In other words, we would be going this way. And notice that now it's no longer upper curve, it's the greater curve is the y plus 2, and the lower one is the y squared. And I need to know what the y values go from. Well, the y values go from 0 down here to what is the y value at this point?
4. Wait.
That was the x value.
Sorry.
2.
So it was 2. So we're going to go from y equals 0 to y equals 2. So the area is going to be the integral from 0 to 2 of the upper one, the larger one, which is the y plus 2, minus y squared dy. Nice thing about that, only one integral. Yes?
Why is x equal y plus 2 is bigger here on this one?
So if I substitute in, say, 1, what's the x value here? What's the x value here?
What?
So this one's bigger.
Oh.
When you're doing it this way, it's which one is further to the right as opposed to which one is higher up. Okay? So then, let's see, we're going to have 1/2 y squared plus 2y minus 1/3 y cubed. So substituting in, that's going to be 2 plus 4 minus 1/3 times, oh, sorry, that's not right. Yeah, that is. So that's 6 minus 8/3. I did something wrong on the previous one, apparently, because this isn't going to come out to be that at all. That's 2 2/3, so this is 3 1/3. I believe that's the correct answer. Let's go back to the previous one. What in the world did I do wrong? See, we had the integral from what to what? 0 to 1 of,
I think it was 0 to 2 of x, or square root of x, x to the 1/2. Plus, or dx, plus the integral from 2 to 4. The x to the 1/2 minus x minus 2.
I did something wrong on this then. 2/3 x to the 3/2. This is why I should have my notes out instead of just doing these.
And Lynn's not here today. You know?
Lynn's not here
She would know.
to lend me.
Yeah.
I think this is one out of y'all's textbook. If it's not, I may be in trouble. (8.2) Dun, 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 dun.
I think it's when you're plugging in the numbers for 2 to 4 that you roll. Remember
Yeah, it should be 3 1/3. So did I have 2/3 x to the 3/2 from 0 to 2
Yes.
plus 2/3 x to the 3/2 minus 1/2 x squared plus 2x?
Yes.
So I did all the calculus part right.
When you were substituting, you had 0 minus 0 plus 0. I don't know if that's.
Well, when I substitute in 0, all those are going to be 0. I think I'm losing my mind. All right, so this is going to be 2/3 times the square root of 2 cubed.
2 square roots of 2.
Yeah.
Yeah.
So that's 4 square roots of 2 over 3.
Yeah.
Plus, I'm not getting the answer that they're getting, and I'm not sure why. I'm doing something stupid, I'm sure, but I'm sure I don't know what it is. Because that's 16/3 minus 8 plus 8 minus, those are all 0. That's the answer that I got, isn't it?
Yeah.
Well, crap.
You get around 6 or
Okay. No, this is not the answer that your book has.
Oh.
Is it supposed to?
It's supposed to come out to be 3 1/3.
Was the region on the second one supposed to be from 2 to 4, or is it supposed to be 0 to 4?
No, it's supposed to be from 2 to 4.
You have,
Oh, from 2 to 4.
yeah,
Nah.
Oh.
That's what I was trying to say.
Thank you. So this is going to be 2/3 of 2 to the 3/2, which is 2 square roots of 2. There we go. Minus 2 plus 4. And I'm going to assume that comes out to be 3 1/3. I've spent more time on this than I should have. Sorry, I wasn't following you, Brett. Did I get 3 1/3 on the second one?
Yes.
Yes.
And then there's a third way.
Yeah.
Subtracting areas using basic geometry. So again, we'll look at our graph. Which looks like this. If I do the integral from 0 until 4 of the square root of x, that gets me everything underneath this curve all the way to here, right?
Yes.
And all I got to do is subtract out the area of this triangle,
That's so easy. Do that way.
which is a triangle with base 2 and height 2. So this is 2/3 x to the 3/2 from 0 to 4 minus 2. So that's 16/3 minus 2 is 10/3, which is 3 1/3. Sometimes it's much easier to think a little bit before you just start jumping and dividing it up into lots of little regions. That and the numbers turned out to be a lot easier too, didn't they?
Oh, yeah.
I didn't have to mess with the square root of 2 cubed,
No.
which I mishandled rather badly. All right, last one. Find the area of the region enclosed by y is equal to x cubed and x equals y squared minus 2. What the heck? Okay, I think I can graph that. Y equals x cubed, that one I'm pretty sure of. And x equals y squared minus 2. So when y is 0, x is negative 2. Somewhere over here. And, oh, yeah, this is going to be a right-facing parabola. So I want the region inside of here. Now, with this one, I have a very real problem if I do it in terms of x. And that is this. If you notice right in here, it's going between that same curve twice.
Yeah.
That's a problem. You can do it, but you would have to do the positive square root and the negative square root. Much simpler would be always to go from left to right or right to left. Then it's always one curve on one side and one curve on the other side. So let's see what we can do with this. We need to know where they intersect. And if I'm going to do it this way, I only need to know the y coordinates where they intersect. Okay, so putting x cubed, let's see, this would be y is equal to y squared minus 2 quantity cubed. Gross. So y would be, I don't want to do that. Do you want to do that?
No.
No, me either. So let's go the other way. So if I put this in for x, x equals x cubed squared minus 2. Also gross, right? Either way, it's pretty nasty. Okay? Maybe I can guess. If x is 1, y would be 1. If x was 1 here, all right, what if x is negative 1 at this point? Does negative 1 work? As a matter of fact, it does. Good guess. And it really is a guess because I mean, obviously I haven't looked at this in a year. And what about over here? One, one.
Should be longer there.
Yeah, I don't think it's 1. It looks like the x is going to be bigger than the y, right?
Yeah.
Maybe 4, 2? If x is 4, no, y is not 2. Other way around, 2, 4? No, 2, 8? Boy, after getting a really lucky guess the first time, not so much the second one. All right, well, let's see. This then would be y squared equals x plus 2. It's still gross no matter what you do, isn't it? Okay? On a problem like this, it is likely that they're going to give you the intersection point. Not for certain, but it's likely that they'll give you the intersection point because it is kind of ugly. I don't know what it is. We could find it though. This is y is plus or minus the square root of x plus 2. So on a calculator, I could go, okay, I only want, this is clearly the positive part. So the square root of x plus 2. And this is x cubed. And there's where they intersect. I'm going to guess 1.414. Ah, well, that's not bad. 1.21, etc. And I don't really want that though. I want the y coordinate. Right? So our area is going to be the integral from -1 to 1.793 yada yada yada. The graph that's further to the right is y equals x cubed, so that's going to be the cube root of y minus y squared minus 2 dy. And it's a matter of putting all that in. Let's see. For the y coordinate, boy, those are hard to read. Notice it has that value in y.
Yeah.
So I can use it or I can store it either way. So math 9 from -1 to alpha y. Oops. And then I want x to the 1/3 minus x squared minus 2. Well, that'll be plus 2, right? Are there people out there?
Yes.
Are there really people?
I mean,
Seems likely. It's thinking.
that was really hard for it.
So about 4.215. By the way, if you ever have that happen where your calculator's sitting there thinking and you're taking the AP exam, don't sit there and watch it.
Yeah.
Move on. Okay? Because every now and then, you'll have one where it takes it a long time. Now, I will say, if it takes it a really, really long time, you're probably not doing it the best way possible. Okay? All right. Y'all have a great weekend.
Do we have a quiz on Monday?
That's a great question. Do we have a quiz on Monday?
Don't think so.
Nope.
Yes.
Oh, can we get our test back from
Yes.
Wednesday?
Let me stop the recording.